Okay, so as I mentioned, Brandon has been kind enough to allow us to set him on fire. So here's the scenario. Brandon, you like to camp?
Like what?
Do you like to camp?
To camp?
Camping. Okay, well you do now. So Brandon's out camping. What color do you want to be?
Red.
Red. He's over here at his campsite. The blue is a river. You with me so far?
Yeah.
Okay. While he's at his campsite, he accidentally falls into the campfire and sets himself on fire. There is no water in the campsite. He's got to get to the river to put himself out. You understand the scenario? More importantly, Brandon, do you understand the scenario? Excellent. Could you come up here, please? Could you please draw the path that, okay, hold on. Let me start with this. Your path would probably be, but we're going to pretend that you still have some rationality about you. Could you draw the path that you would take to go from your campsite to the river? Thank you. Let's give it up for that segment. Well done. You can sit down now. But I have a question for you. Why?
I just thought that it was the closest distance to the river.
What makes it the closest distance to the river?
That's
So let's suppose you took a different path. Okay. Let's make your other path bright green. Let's suppose you did that. Okay. Why is his yellow path, the path that he chose, a better selection than the green path?
Because the green path is longer, so he'll burn to death more if he takes the green.
Well, you can't be more than dead.
Well, you know what
There's
I
not varying degrees of dead. I mean, dead is dead. You can't kind of be dead.
I mean, I know.
Right. So it's either dead or dead.
You know what I mean?
Yeah, I know. Yeah. He'll burn longer.
Yeah.
Why?
Because it'll take longer for him to get to the river.
Why? Anybody else? Why is the green path? Do we all agree with that statement?
Yeah.
The green path is longer than the yellow path, so Brandon chose smartly. Yes? So why is the green path? How do we know that the green path is longer than the yellow path? Oh,
If you drew two like vertical lines, so one vertical line through the point of B, and one just like through the blue line, you would be able to tell like the slope of the blue line and where it would be closer. I don't know, it's just like perception. Like,
I understand.
you look at that and you're like,
okay, Danny?
it looks closer.
It looks closer. Katya?
it's straight as a river, it's not like diagonal.
Yes, but how do we know that it's shorter? No.
Perpendicular.
Oh, I'm sorry, what?
It's perpendicular.
I don't like pronouns. What's it?
A line, that Brandon's path.
Brandon's path? Brandon, did you intend for this to be perpendicular to the river?
Yes.
Good. Okay, so we now realize that you were smart enough, while on fire, to calculate the perpendicular distance to the river. Right? Okay, I can accept that, but we still haven't answered the question. How do we know the green path is longer than the yellow path? Lucy?
Because if it was perpendicular, then it would be the hypotenuse.
Oh. Does that make sense to everybody? No? Okay. Explain.
So like
Is not a good way to start an explanation. Come on, I'm recording. Clean it up.
If it's a right triangle, because it's perpendicular, the hypotenuse is along the side of the right triangle, and that's what the green line is.
Perfect. Now everybody got it? Any other path that Brandon would have chosen? Okay. This way, this way, this way. All of these are hypotenuses, whatever. A lot of hypotenuses. However, the shortest distance that he can travel is along that yellow path, because that yellow path becomes a leg of the right triangle. All of those other ones, the reason they're green is because they're all hypotenuses of some other right triangle. Everybody get that?
Yes.
Okay, we can't move forward till I'm sure everybody understands it, because this is going to be crucial to what we do today. Okay, we're good?
Yes.
Speak now or forever hold your peace. Beautiful. Okay, then let's proceed with the problem. Yes? Oh, yeah, Riley. So Brandon has an infinite number of ways to get to the river. We all agree that he wants to go in a straight path to the river, correct? He's not going to go backwards, right? This just doesn't make any sense whatsoever. So we know that he's heading towards the river. He has an infinite number of ways to head to the river. All of those, I drew 6 possibilities to get to the river, the green ones. Any one of those green ones becomes the hypotenuse of some right triangle. Okay, so for instance, let's get another color involved here. This triangle.
So it's just the background?
Say again?
It's just the background?
Correct.
Oh.
Yeah.
I get it now.
Okay, beautiful. Anybody else? We're good? Okay, now that you understand that scenario, we're going to do some math. Okay, let's go back to blue. You know what? That's a little sloppy. Let's go here, and we'll go with line. What the heck just happened? Okay, that's great. And Brandon wanted to be red, so we'll put him over here. Brandon, do you have any brothers and sisters?
I have one brother.
One brother. How old is that brother?
He's 17.
He's 17, so he's older than you.
Yes.
That's not a good thing, is it? Just say it's not a good thing.
It's not a good thing.
Okay, good. So we're going to make that negative 17. You are located at the point 1, comma, negative 17. Okay. Jackson, what number do you wear on your football uniform? 14. And how many fingers do you have? 9. Okay, great. Okay, good. Thank you. And Lucy, how many pets do you have?
0.
Okay. 0. And Lucy, how many pets do you wish you had?
3.
3. And if you took the 3 pets that you wished you had and you counted all their legs and added that up, how many legs would you have?
12.
12. And it's kind of a bummer that you don't have any pets, so we'll make this a negative thing there. Okay. We're going to do the same thing that we did before, except now I'm giving you coordinates of the river, and I'm giving you coordinates of Brandon. And we want to calculate how long or how far he has to run to the river while on fire. We're going to go back to yellow. And we're going to find the length that he has to travel, and we'll call it D. Okay? The ultimate goal of this problem is to figure out how far he has to run while on fire, given those coordinates, those random coordinates. How do I do this? Logan. Is not a good way to start an answer.
Is the intersection between the line D and the pink line the midpoint of?
Nope. Could be. We don't know that.
Oh,
Oh, back to you, Logan.
well,
Is not a good way to start an answer.
to find the distance of line D, you find, you'd find the distance between B if it was on the pink line from, I think it was Jackson's point,
Oh,
14
well, that's,
feet.
so just so we can talk, let's call this, we'll call this aardvark and this kangaroo. Okay?
You find the distance between point B and K on the pink line, if B was on the pink line.
Okay. Uh-oh.
No.
No.
I'm lost.
Okay, any other ideas? By the way, I'm not giving you this. You gotta figure this out. What do we do? Juliana, go ahead. And then what? Go in. Is not a good way to start a sentence. Okay, and then what? Then what? Okay. Lana? You just rattled off the slope equation? Okay. That's relevant, but I'm gonna need a little bit more juice on that one.
So use like subtract, like the miles to get the sum. So divide
Wait, hold on. I'll come back to you in a second. Okay, Lucy?
You could find the distance between B and K, and then, that would be like the, oh wait, no, never mind.
Okay, Danny?
KA is one big triangle, I mean, there's a difference between B and A, B and K, and A and K. But it's just a triangle.
Yeah, but we don't know what kind of triangle BAK is. Are you assuming that BAK is a right triangle? Badger, aardvark, kangaroo? We don't know that. Zoe? Oh, you pull that arm back in. Oh. Yes?
Could you, sorry, could you make like two right triangles and like solve for the distance between B and A and then have the right,
Okay. So then,
could it be, wait, this line, would that be like in the midpoint?
could be, but we don't know. For discussion purposes, let's get, we'll call this LABA, just so we know, we can refer to that point. I'll ask you one more question and then I'll leave it up to you. If you knew where L was, could you solve the problem?
Yes.
Yeah, it's completely irrelevant to the river then, because you're just calculating the distance between the badger and llama. Okay, now, my picture is a little deceiving because it looks like L is the midpoint of AK. That's not the case. A and K are random points on that line. So I'll ask you again, how do we calculate D? How do we find the distance that Brandon runs on fire? I'll give you one more hint. This is an algebra problem, not a geometry problem. See?
Could you like find the slope between A and K, and then find,
Oh, hold on, let me answer your question. Lana, so I'll come back to you. Could we find the slope between aardvark and kangaroo? Good answer. Don't go anywhere, I'll come back to you in a second. Back to you, Luz.
so the slope could help you find what point L was,
Huh.
maybe?
Oh,
I don't actually know.
I like you put the safety net in there, maybe. Like I might be completely wrong, but maybe. All right, go. Calculate the slope of AK. That's a good place to start. Let's say the slope of a k equals. Leave it in fraction form, please. I know some of you wrote a program because you went bonkers with your programming, but I'd like that in fraction form, please. Michael, what do you got?
I don't know.
Yes, you do. It's right there. I just saw it on your iPad. What do you have for an answer? 16 over negative 9? Somebody confirm?
I got
2 over 2.
3 over 2.
3 over 2?
Yeah.
Yes?
Yeah, I did.
Okay. All right.
Oh wait, that's why I put 14.
Ah, there you go. Yeah, you're crazy. All right, so that's a good start. We're getting somewhere. Now what? Come in.
Don't you just point slope form?
Oh! Write the oh, sorry. Of what?
Of B with the slope.
B's a point. How do you do a point slope form of a point?
Line B, like line B.
Line BL. Interesting. Okay. So can you write wait, hold on. Can you write the equation of the line BL yet?
Yes.
Yes?
Yeah.
How?
Because it's the opposite slope.
Oh, okay, hold on. So you know the slope of BL?
Yeah.
What's the slope of BL?
Negative 2/3.
Or as my grandfather would say,
2/3.
yeah, negative 2 turds. Okay, so let me get back to you. If we know the slope of BL is negative 2 turds, then, you know what, not for you. Everybody, write the equation of the yellow line then, please. Because what are the two things you need for point slope form? Yeah, that's why it's called point slope form. Very good. Okay, we got it?
Yes.
Lily, what's the equation of the yellow line? Ava?
Y plus 17 equals negative 2/3 x, or parentheses x
Say what? I didn't hear the last part. X?
minus 1.
Well done. We're so close. We're so close. Okay. Big deal. I now know the equation of the path that Brandon runs along. But that's not what I'm looking for. I'm looking for the distance. So now what? Distance formula? Not yet. Because we're missing one crucial piece of information. We're missing point L. If I know the location of L, then I can just plug and chug in my calculator and everybody's happy. How do I find where L is located? Oh, I mean, you can, yes, but it's not going to help us. No, guess and check would take forever. Yes?
Could you just put it on graph put the lines together?
No, because you'll see when we solve this problem, if it is a nice, pretty answer, I will eat this chair. We randomly pick numbers. The odds of it being something pretty like 1, 2 is not going to pan out very well. I sure hope it doesn't pan out because I don't know if I can get through all that mess. In other words, the answer is probably gonna be ugly. Okay, what did we not do yet?
Find the distance.
Correct, but we can't find the distance yet because we don't know L. So how do we find L?
Find out.
Nope, can't, because we don't know L. If we, hold on, let me finish my statement and I'll come back to you. If we knew L, then we could do Pythagorean theorem, but if I knew L, why would I do Pythagorean theorem? Because I could just do distance formula. So again, we're almost stopped here, and in order to get past this, we need to know, how do I find L? Lucy, you were gonna say something.
No, I realized that it didn't make sense, sorry.
Okay. Were you gonna say something ridiculous, like?
No, I thought I was gonna say something that would help the problem, but then I
I
realized
got
it
you.
didn't make sense,
Okay.
so.
Because we don't know that that's L. You'll see. So, me? There's the again. Kurt, you're changing it to term. You're not going to stop saying something before the sentence, you're just going to change it into something else? No, I think that. What else? Okay. What else? We did that, that's the yellow one.
No, the other one.
Oh! Who said that?
I was just like,
Well, why didn't you tell all of us? What, are we supposed to be psychic?
I thought that was wrong.
Oh, I don't want to be wrong. People make fun of me. Oh, I'm afraid I'll be. This is what's better, being wrong or me mocking you in front of the whole class? Oh, there's the other. All right. Write the equation of the purple line.
Oh, wait. Which one's?
Which one's the purple line? One slope form.
No, which one's X2? Like
It's up to you.
Okay.
Some of you might choose to use A, some of you might choose to use K. That's one of the great things of this country. You can do whatever you want. By your power, right on.
I love it. I'll use writing. Yeah.
Logan, write the equation of the purple line. I'll get to that in a second. Just do what you're supposed to do and quit bugging everybody. Leah, what do you got?
Y minus
Hold on. Go. Y minus.
y minus 9 equals 3 over 2 times x minus 14.
Wait, how'd you do that?
Magic. Yes?
Could you just do like y equals mx plus b? Or
You
do
could
I-
because notice there's a 0 here.
Yeah.
Yeah, but you don't have to. I mean, she chose to use
What's easier?
easy is relative. I would have done 14.9.
Okay.
Okay? All right. We're making progress. So now I've got the equation of, hold on, let me finish my sentence. I've got the equation of the purple line. I've got the equation of the yellow line. How the heck do I find L? Go with me.
Don't you do like, well, I just start with this one.
Okay, yeah, you worked it in later. Go ahead.
Don't we should do like the, I forgot what it's called, like when you.
Could you describe it? Sounds like could you use charades?
System of substitutions. Yeah. Substitution.
Solve the system of equations.
Yeah.
Because as I said a gabillion times, what does a system of equations represent? It represents the point of intersection between two lines.
We did it.
Okay? No, you're not done yet. Solve the system.
Oh.
This will be the fun part.
I don't know. You should just disconnect your iPad. Use your video.
Because then you have to find the distance. That's not
Wait, how do we?
Better know. Substitution or elimination.
How hard to do it? It's just a word.
I think I messed them up.
I see what you're doing.
I do.
Okay, so
Okay, so as you're working, I'm going to continue to talk. Here's the harsh reality. We're not going to spend more time, we're not going to spend more time on solving systems. We're not going to spend more time writing equations of lines. We're not going to spend more time doing slopes. At this stage, you are expected to know how to do that. If you can't do that, that's going to require some work on your part. And these equations are going to get ugly. Notice I randomized this problem by just asking stupid questions of people. The answer is probably pretty nasty. So you should know how to do things. I'm not yelling at you, by the way, I'm just talking. You should know how to do things like writing equations of lines. You should know how to solve the system, regardless of how ugly the problem gets. Okay. And this one, I think, is probably going to get pretty ugly. You're not using it?
Stop.
I see what you're doing.
Please stop.
Hold on.
Aren't you supposed to have -12 at the top? I'll use the white.
Thank you. Good catch.
I'm actually just looking for both lines.
I know it's been just crash.
I'm figuring it out.
Well, my knowability is first. I really don't think. I mean, like, we're parking wide out.
Uh-oh.
I'll look at it.
You might have to eat this year.
Oh, no.
It's -2, -9.
No, it's not. Is it really?
Yeah, it is. That's, I got -2 as well. Oh my gosh.
Hold on. Shut it. Wait, you sure it's not -15? Okay. Did I do that right?
Get your fork and knife.
You haven't finished the problem yet.
X is 2?
Negative 26.
I did the solo, I got 1,105 for X.
Oh,
Over 18.
might have done something wrong.
No, I got negative 22.
I don't think so, that's not about right.
I got infinite with many serious.
Wait, I got negative 22.
I think I wrote it down wrong. Wrote it down.
I'm pretty sure I'm right.
Yeah.
Wait, it's
Wait, now that's, we haven't done D yet.
Oh, he
Okay.
makes me white.
But Miss
Yeah.
Brady, you never
Yeah.
know. I think we should keep the cookie knife right.
Yeah, I'm getting a little nervous right now.
If you wanted a list, you don't have to use the chair.
Hold on, let's see.
One and a half.
I think I'm gonna be okay. Okay, so hey, stop what you're doing. So I'll say this also. When we're doing a lesson like this, if you choose to just sit there and watch, you're not going to get anything out of this. So I see some of you haven't even cracked open your calculator. Some of you don't have anything written on your iPad. Whose fault is this when the first quiz comes around then? Yours, right. So this isn't middle school, this isn't elementary school. I'm not gonna police this. If you choose to sit there and do nothing, don't be surprised by the results. If you get in there and get your hands dirty, I guarantee you'll know better what's going on. What's the last step to solve the problem? Distance. Now, the nice thing, and the reason why we spent a week doing coding, is that's not a big deal. You bust out your calculator, you run your distance program between 1, -17, and -2, -15, and we pray
Wait, what two numbers?
that, you tell me. What two numbers do you put into the distance formula?
9, 15,
B, Badger, and Llama.
Oh.
Just go with 13.
So wait, hold on. Let's talk about how to show work. So you'll see in this problem, I tried to incorporate a lot of different colors. But now you're just going to use your calculator to get the answer. How do I know that? Well, this is what I want out of work from you. Let me move this up a little bit. Okay, that's what I'm expecting for work. Now, what does that mean? You're telling me I use my calculator to find the distance between the point 1, -17, and -2, -15. If numbers just magically appear out of nowhere, I don't know what distance you calculated. So I'm going to expect you to list the points that you found the distance between. And that answer is?
Let's go with 13 or 3.61.
Oh, thank goodness. 3 decimal places, Michael. 3.61.
It doesn't.
That just gives us
Yeah.
2.61.
Yeah, we programmed it only to give us 2.
Oh, gotcha. Okay. I didn't give you units. Brandon, let's hope for your sake that that's inches and not miles.
Yes.
Okay, but just to make things interesting, let's make it meters. So you get a little bit of crispiness going on there. So let's review how this whole thing came about. Going back to the original problem, Brandon is at his campsite, he bursts into flames, he runs to the river. We agreed that the shortest path for him to follow is along a perpendicular. Now, that's just an example of what we're doing algebraically. Algebraically, we're saying that the shortest distance between a point and a line is along the perpendicular. Without that line, the yellow line and the purple line being perpendicular, the problem's not solvable. Okay. We calculated the equation of the purple line. Well, we kind of went out of order. We found the slope of the purple line, and then what we could have done right away, but you guys missed that point, was write the equation of the purple line, because we had the slope and we have 2 points. Doesn't matter which point you choose, it's entirely up to you. That gave me the purple line over there on the left. Then, I forget who it was. Juliana, was it you that recognized the slope would be a flopposite? I want to give you credit, okay. Juliana recognized and shared with us that the slope of the yellow line would then have a flopposite slope, so we can find that right away by flipping it over and changing the sign. That allowed us to write the equation of the yellow line. The yellow line and the purple line intersect at the point where Brandon enters the river. That's the point that we need. So we solved that. That's what all that white work is. It's the system of equations to find the point of intersection. Because you'll remember, like I said, way back when, solving systems, I kept burning into your brains that a system of equations is the point of intersection between the two lines. That allowed us to find the nice pretty point of negative 215, which made me very nervous that I would be dining on a chair. But fortunately, when we plugged that into the distance formula, we got a not so pretty answer of 3.61. Pretty good. Question?
How did you get y equals 2 over 2x minus 12?
Oh, great question. I took this equation, the purple equation, distributed to 3 halves, and then moved the 9 to the other side so that I knew what y was. And we talked about all the different ways that you can solve a system. I could have written everything as y equals and then set the two things equal. I could have done a system using elimination. I could have moved the x's to the other side. You've got a lot of different possibilities. Better. Huh? Okay. Glad I could help. Yes. Yes. Because I took this, subbed it in there for y. So y became this expression, then I still had to send it. Yeah. 100%. Yeah. Any questions about the process? Okay, here we go.
This is gonna be all our homework. We're taking like 10 problems with this. It's hard and hard.
Find the distance
That's crazy.
between x and the purple line. Go.
I don't feel like it.
So you can say slow form.
I am so ready for this.
Yeah, so I'm finding this little bit.
No, it's the line between x and the line between.
That's crazy.
That's 7, negative 10.
7, negative 10, yes.
We're finding the slope, right?
Yes.
This is right.
You can put slow. If I put the right values on the right spot. I got 50 over 52. So when this is flop, this cancel the x, all this doesn't so. We are to. I'm so confused on what you do.
Everybody's in a different seat. Who's missing?
What should be missing? We're just finding the line, right?
Oh, yeah.
Thank you. You're finding the distance between x and the line.
Sure. So we put this.
Just to keep things the same, I'll label these points for you. so we can talk about common points. Let's make this point P, and we'll make this point Q, and then we'll make this point R.
Oh wait, this year I don't know. So I put it wrong on 7. Should I? Oh, and then. Oh, I know. Sorry.
I have that, this is not top one.
Oh, I'm flipping these.
What do I do? I can put this into Y. Do the top one, because the top one's supposed to.
I mean, one way to do it would be Y 15 seconds, and then 10 to the other side. Do the same to the bottom equation, so then Y 7.
Whatever works for you. Say Y, then you just plug in the top.
My brain cells are dying.
First, I'm gonna go.
Look over my work. I don't know if I did this correctly. I don't even know if I did this. Does this make sense?
I understand the way you did it. Because that's why I'm also So you still want to 5? We'll have to 5 everything.
Stop what you're doing for a second. Two quick things. Shh. Two quick things. You're on Notability. I would highly recommend that you start incorporating colors into your work more, because things are going to get more challenging in the future. So colors will help you keep track of what it is you're doing. If everything is the same color, you can't tell what is what. Second thing, before I forget, you have a quiz next class. That will be on Tuesday, covering days 1 and 2, not this.
Thank God.
Oh my God.
Are you sure it's 105? Because look at this now. This is all over.
Well, 7 times.
I think I messed up somewhere. I did the correct steps, but I messed up
Like you made them eat right now. Okay, so that's correct.
Y minus y1 equals f times 20 x minus x 1.
Not zero. I have the right idea, but I feel like it's too greedy and I think it's wrong. I don't know what I'm doing.
No, I just tried that. I just didn't, oh, yeah,
I have the right idea, but I just don't have the right things.
Oh, I got one. I got x equals 1. I type that in. Is that what you got? I got one x factors.
I thought 13.2.
Like, I added everything.
So let's go with it.
So I added everything.
By the way, I have a first answer. It might be right or wrong, I don't know, but 10.51. So,
Wait,
as you're moving forward.
I got one.
I don't know if it's right or wrong, I'm just telling you, I have an answer. I didn't do the math.
I know what do I do after this at the top? These are the exact same x's. What do I do? Yeah, what do I do if I have 15x and 15x on both? I'm like different. What I did.
What's
15x minus 1 to be right. 15x minus 1 is to be 2. I don't know why I messed up.
Where's my x? Wait, I got space.
Oh, we also have an answer of 9.76.
I got 10.51.
I got a 10 point, oh, 10.51.
Yeah.
What do you do?
I'm going to see if I can do that. I'll leave this down.
Isn't that when you start just acting? That's the same denominator when you're subtracting, right? The denominator is 7.
I'm at right now.
I think got it.
Why are we talking about
Where do you get your answer?
the chance line and
Don't be now. Nice.
What'd you do?
We always
What do I eat?
So you wanted to like shoot?
we did a map and I was like, last time you went pretty
I'll cheat for 30 seconds.
Yeah, same for your watch. I finished eight watch and did first activity. So the last 5. So it's not like 48. It's not like 6.8.
I used to sit That's what that's how I guess it's like 37. I had 37. It was because I had lost
I got 1 and then 6.8. Oh, I had a question.
One hundred is five.
Wait, I think I want to apply. I multiply. Oh, I think I know why I got wrong. Is that one that they're both the same?
Wait.
How's Logan doing?
That's 75. I got half of that correct.
I forgot to flip flop, that's why.
I got half of that correct.
What'd you get for it?
10.5.
Yeah, when he said you have right, but then.
Oh, I plugged it wrong. I plugged it in wrong, that's why. I plugged it into the wrong equation. I'll plug the one that.
I got half of it correct. Mine brings self.
I'm just gonna be right.
I got this correct.
How do you find it?
I don't know how. I did.
Everything is shameless.
I made a mistake. I plugged in the wider stuff to one You're right, Jim.
No, stop.
That is equal to. Chicken is also good.
Okay, so here.
Is that right?
Yeah, that's what I did.
Yeah.
Logan, guess what I got?
Now you have
You multiply it by the wider.
Mine brings self.
I got one.
I got the 37. Not that anything else.
Just tell me because I messed it up. I accidentally plugged in the wider stuff to
Can't solve.
I'm like, I was so.
Oh my gosh, wait.
Oh, I think it was.
Wait, did I actually get this correct? I got this right on purpose. I got this right on accident.
I don't know. Did you get 1442 or 137? Okay, so that's all correct. Okay, so stop what you're doing for a second, and let's look at my work up there. First of all, aside from the fact that it's gorgeous, I know that's what you were thinking initially. What I wanted to point out is a couple things. Number one, there's a lot of spots to make mistakes up there. The most common mistake that people make is a sign mistake. I've already made one today. For instance, when I distribute the 15/7 to the -7, remember that number has to be negative. So this number here, 105/7, is supposed to be negative. When I move that 10 to the other side, it becomes negative. For the most part, from my experience, people understand the geometry eventually pretty well. They screw up on small things like that. This is about as bad as it gets. I did not expect it to turn this ugly. Okay? But it did. And realistically speaking, I've given you all the tools to be able to solve a problem this bad. I've shown you how to convert decimals back to fractions. I've showed you how to get rid of ugly denominators. So you'll notice I didn't want to multiply everything by 105. So I did it by 7 first to get rid of the 7 denominators. Then I multiplied by 15 to get rid of the 15 denominators. Did the numbers get big and ugly? Yes. But who cares? Because I have a calculator. Well, I stole a calculator, but go from there. I didn't finish the problem because you all know what to do now. What does that x and y represent? It represents the location of r, and then I can find the distance between x and r. There's a lot going on that screen. Part of it is geometry, but 90% of it is algebra. Whoop, come on. There we go. There we go. Okay. The geometry aspect is simply the idea of why Brandon ran perpendicular to the river, and the fact that all the other paths are hypotenuses. Not good. Once we get to the point that there's a right angle down in the corner, everything else becomes algebra.
Why?
These take a while. Your homework for tonight is only, I believe, 3 problems.
Because it's all this.
Because it's all this.
Are they gonna be like good answers?
I don't remember. But I will also post the answers so you can check. Now, last thing I would say, let's suppose you do this problem and you get down to x and you realize you get 1,000 over 9. The hardest thing of all of this stuff is to be able to go back and find your mistake. So I'm going to ask you, more so than anything we've done this year, you need to be tenacious. Just because you get the wrong answer doesn't mean you can just throw your pen down and stop working. It also doesn't mean that you need to go back to the beginning and start all over again. It's just like debugging your codes that we did this week. If it doesn't work, if it's not the right answer, go back and try and figure out where the mistake is. The only problem with these is there's no go-to button that'll tell you exactly where the mistake is. Okay? Questions? We're good? Don't forget there's a quiz on Tuesday on days 1 and 2, and you have day 3 for homework.
Oh,
Day
sorry.
3.
What was the answer to this?
10.51. By the way, Amelia got the answer first. I didn't want to give her credit in case it was wrong, but let's give it up for Amelia, huh? Well done. Now, what a lot of you are going to go through is exactly what she went through. This can't be right. Look at these ugly numbers. I did something wrong. I don't know what I did wrong. Oh my God. She didn't do that, but I'm saying you're probably going to. Just because the answers are ugly doesn't mean your answer is wrong. Okay? Beautiful.